Welcome to day 3. Today we've got packet page 15 and 16 for your homework. You got proofs using parallel lines as our topic. Take a moment to pause the video and do your warm-up on your warm-up sheet. And there will be a question that pops up that asks for your responses for each of those. So the first one we should have false. Alternate interior angles are congruent, not supplementary. Alternate interior angles, remember, are formed by our zigzag. So those would be considered alternate interior, or you could do the zigzag going the other way. So those could be considered alternate interior as well. Okay, in a parallelogram or some other shape, okay, they would be like here and here, or they would be here and here for our alternate interior. And corresponding angles are congruent. That one was true. On the homework, we had 1 and 4 were congruent. We should be suspicious. Why are they giving us those when they're outside? Well, we want to do our linear pair. So you can do linear pair implies supplementary angles. That would tell you that 1 and 2 are supplementary, and also angle 3 and 4 are supplementary. After that, we always do our congruent angles implies congruent supplements, and the ones that should be congruent are the ones that we didn't already know were congruent. We already knew 1 and 4 were congruent, so now we know 2 and 3 should be congruent. And that's all we wanted to show in this proof. In the next one, we wanted our triangles congruent. They gave us 3 congruent to 4. That was great. That's one of our angles in there. But they gave us 1 congruent to 2. And we should be suspicious. Why is that being given to us? Oh, we've got a straight line there. We can do linear pairs. So step 4, linear pair implies supplementary angles. So we can say 1, and I called it angle 5. You might have numbered it differently. 1 and 5 are supplementary. Angles 2 and 6 are supplementary. So automatically next, we should say congruent angles implies congruent supplements. The ones that should be congruent are the ones we didn't already have congruent. So we should have 5 congruent to 6. That just gave us another set of angles in our picture. Well, we're out of givens, so look for reflexive or vertical angles. We're sharing CF, so we should do the reflexive property. And we have a side not in between the two angles, so we used angle, side, angle, congruent to angle, side, angle for our last reason. In number 3, we have a perpendicular bisector. And they gave us angle 1 congruent to angle 2, which was not in the triangles. Well, we want to be suspicious of that. We can use the fact that we've got perpendicular lines implies right angles, and say we have right angles there in step 4, so EFA and EFB are right. We can then use our complementary angles one. So right angle implies complementary angles, meaning 1 and 3 are complementary and 2 and 4. You might have numbered your 3 and 4 differently in your picture, so it may not match exactly as what I have written. Then we do our congruent angles implies congruent complements, getting the ones congruent that we didn't already have congruent. So 3 is congruent to 4, and that helps us in our triangles. Well, a perpendicular bisector is also a segment bisector. So next we should do segment bisector implies midpoint, and then we'll do midpoint implies 2 congruent segments. Once we have that, with our other given, that was enough to get us side angle side in our triangles. So today's topic is we're going to do proofs using parallel lines. So on your cards, the second card, not the main card that we had, but the second salmon color card, we have that parallel lines imply congruent alternate interior angles and parallel lines imply congruent corresponding angles. So see if you can find those two on your second card. And those would be ones that you want to bend backwards and start studying. Those are the 2 new ones that we will use today and that you should spend some time studying tonight. So again, that's the parallel lines implies congruent alternate interior angles, and parallel lines implies congruent corresponding angles. Let's start out with our basic rigid motion here. we would want to do a rotation around point C of 180 degrees, and we would have triangle ABC maybe, or you could do the other triangle as well. Feel free to always write that out in a sentence if you don't like doing the transformation notation. So we'll get down our statements and reasons and do our givens. All right, and from our givens, we want to mark up our picture. When you have parallel, we mark that with an arrowhead. So we'll put a single arrowhead on each of those. We also have BC congruent to DC. Now just note that arrowhead is not meaning it's congruent. So we can't use that side in like side angle side or angle side angle or anything. It just tells us that it's parallel. So from parallel, we can use our alternate interior angles. Alternate interior angles, we want to look for a zigzag. If we made a zigzag going this way, our alternate interior angles would be here and here. So we're going to be able to say in step 3 that angle B is congruent to angle D. But we could also do our zigzag going the other way. We could go like this. Now the flat parts of your zigzag should be along the parallel lines. So doing the zigzag going that way, that would give us angle A is congruent to angle E. And our reason is just one of our new ones for today that, again, you have on your second card there, is parallel lines implies, oops, need the arrow there, implies congruent alternate interior angles. So this gave us a side, this just gave us two angles. Now we could have just done one of those alternate interior angles and then also done vertical angles. That could have worked as well. Notice our side is not in between the two angles. So we are going to say angle, angle, side is congruent to angle, angle, side. And our statement is just that our triangles are congruent. As we move on to number 2, we'll start with our basic rigid motion. And for this, we want to slide one of the triangles down to the other. So we're going to do a translation. Let's say that we want to translate, we'll take this C and want to bring it down to the B right there. So we're going to go a vector from C to B. And if we're going C to B, that means we want our triangle to be the top one, triangle BCD. And you could have slid it other ways. You could have done from D to E of that top triangle. You could have had the bottom triangle and slid it up. There are a couple of different options for how we could have written that. If you're unsure of the transformation notation, again, always just write out a sentence. And let's go ahead. We'll get our givens down in statements and reasons. So let's mark in our picture. We've got BD parallel to AE. So we'll put our arrowhead on there. BD is also congruent to AE, so we can put our mark for congruence. And we've got AB and BC are congruent. Well, with our parallel lines, if we did the zigzag, one of those angles is not in the triangle. So that might not help us in this case. So let's look for corresponding angles. So just a review of what corresponding angles are. They're angles that are in the same spot in the intersection. So that angle and that angle would be corresponding. This angle and this angle would be corresponding. This one and this one would be corresponding. And that one and that one would be corresponding. So think of it as like the top left, top right with top right, and so on. I think it's helpful to pick out corresponding angles sometimes to extend the lines. Well, notice this angle right here is in the top right of that intersection. This angle right here is also in the top right of that intersection. So I'm going to maybe number them 1 and 2. And we can say that angle 1 is congruent to angle 2, with our reason being our corresponding angles reason. Parallel lines implies congruent corresponding angles. So we'll mark those in our picture. And notice now we have an angle between two sets of sides. So we can do side angle side is congruent to side angle side, with our statement being that our two triangles are congruent. Moving on to our next one, our basic rigid motion is a pretty familiar one. It's like that bow tie picture. So we've just got our rotation around point C of 180 degrees of triangle, and we'll just pick one of them, ABC. And from there, we'll do our statements and reasons and get down our givens. Alrighty, so we've got AB parallel to DE, so we can mark those. So from those parallel lines, we can do our zigzags. Doing our zigzag going this way, we can get angle A and angle D congruent. Doing our zigzag going that way, we can get E and B congruent. So we can have angle A congruent to angle D, and we'll also have angle B congruent to angle E, and that's by our alternate interior angle reason. Parallel lines implies congruent, alternate, interior angles. Well, our second given there we haven't used yet. That's bisects with a segment following it, so that's segment bisector. Implies midpoint. BE is the one being bisected, so our statement would be C is the midpoint of BE. So automatically, next, we should do our midpoint implies two congruent segments. C was the midpoint of BE, so our two segments should be BC is congruent to CE. We set it in our proof so we can mark it up in our picture. Well, notice now we have a side and two angles, and the side is not between the two angles. When the side's not between the two angles, that's angle, angle, side, congruent to angle, angle, side. And our statement is just that our triangles are congruent. Triangle ABC is congruent to triangle DEC. Moving on to number 4. We can't just reflect this one because C wouldn't match up with A. There's not just a rotation, so we're going to have two steps. So we're going to translate, and we're going to slide B to D. And that'll be for triangle BCD. Because then that would essentially give us a triangle kind of like that, and it would turn it into our bow tie picture so we could do a rotation of 180. So after that, we could rotate around point D 180 degrees, triangle B prime, C prime, D prime. Again, you could also just write that out in sentences, and that would be perfectly fine as well. We'll take a moment to get down our statements and reasons and put down our givens. So we're given BC, oops, and I forgot my line over the top. BC is parallel to AD, so we'll put on our arrowhead to show parallel. AD is congruent to CB, so we can put our mark on those. So from our parallel, let's do our zigzag. The flat part of the zigzag should be the parallel lines. So let's number those angles because we can't just call them B and D because there's multiple angles there. So we'll have angle 1 congruent to angle 2. And that's our parallel lines. Implies congruent, alternate, interior angles. Well, next, we've used up all our givens. We don't have enough yet, so let's do the reflexive property. We can do BD congruent to BD by the reflexive property. We now have an angle in between two sides. So this will be angle side angle congruent to angle side angle. And our statement would just be our two triangles congruent. Triangle ABD is congruent to triangle CDB. Oh, I messed that up. We have an angle between two sides. Sorry about that. Angle between two sides. So in step 5, we've got an angle between two sides. So we've got side angle side is congruent to side angle side. And our statement, we've got triangle ABD is congruent to triangle CDB. All right, the last one for this video, we want triangle ABE, this triangle here, and triangle DCE. Well, BE and CE are going to be congruent. So we're going to want to flip this over. So we're going to reflect and pick one of your triangles. So we'll say triangle ABE over the perpendicular bisector of AD. Because that line is not actually drawn in, so that's the best we can do to describe it. And you could say the perpendicular bisector of BC as well. That's the same thing. And we got a whole bunch of givens here. So we'll go ahead, do our statements and reasons, and get each of those down. All right, so we got our sides marked. We've got EBC. This angle here is congruent to ECB, so that angle there. We've got BC, so this one is parallel to that one. And we've got a midpoint. So let's maybe start with our midpoint. So we'll do midpoint. It implies two congruent segments. They told us E is the midpoint of AD, so that means that AE should be congruent to ED. We set it in our proof, so we'll mark it in our picture. So we've got two sets of congruent sides in our triangles. We haven't used parallel yet, and they've got those angles outside there as well. Well, what we can do is we can do our zigzag going this way and our zigzag going this way. Let's call this angle 1, and we'll call that angle 2. Well, we can say 1 is congruent to angle EBC. So angle 1 is congruent to angle EBC. And then with the other zigzag, angle 2 can be congruent to ECB. And that's from parallel lines, implies congruent, alternate, interior angles. Well, I want you to focus in on these two steps here. Notice in the first row of 6, 1 is congruent to EBC, and in 2, ECB is congruent to EBC. So then we can then conclude from that that 1 is going to be congruent to angle ECB. And that's going to be by the transitive property. Because the transitive property is used when two things are congruent to the same thing. They were both congruent to angle EBC. Well, now using our second line in step 6 and the line in step 7, those are both congruent to ECB, so we can say angle 1 is congruent to angle 2, again by the transitive property. So we just said 1 was congruent to 2. Notice that's an angle between the two sides in the picture. So that means we will have side angle side congruent to side angle side. And our statement will just be the two triangles that we wanted to get congruent. So E, not C, is congruent to triangle DCE. So that one is definitely a more complicated one, and the most complicated of the ones that we looked at today. So you've got your day 3 homework assignment. You can come to office hours today if you had questions on anything. Other than that, have a great rest of your day.